Good afternoon to all of you. Today in GET session we will discuss how to calculate friction factor in this pipe or in this pipe. And this machine is called pipe friction apparatus. Here you see there are two pipes. One diameter is 1 inch, another one is diameter is ½ inch. Either we can do experiment using this pipe or this pipe. Let us close this pipe so that no water will flow through this. And in this particular experiment, we have to calculate major losses. As you know, there are two types of energy loss. One is major energy loss, another is minor energy loss. And what are the minor energy loss? Loss due to sudden expansion, loss due to sudden contraction, loss due to bending, loss due to fittings. There will be loss of energy due to all these things. These are minor losses, and these minor losses will be ignored, or we will not consider the minor losses. Only we will consider major losses. Major losses means loss of head due to friction. So this is a U-tube manometer where mercury is the fluid. Here mercury is the fluid, and this is the measuring tank where we can measure finally the velocity of the water passing through this pipe using this tank. Now let us run this machine. Here we have to close this one. We have to close this one. We have to open this one, and we have to close this one, so that water will go to this. And here the difference of height in the manometer. This is a glass tube manometer. The difference of height will finally give you loss of head due to friction. HF. HF can be calculated from this difference of height. And here we have to, in order to calculate the velocity of the pipe, what happens? First, we have to open the pipe. Now, let us look at the water from this pipe. All the water has been discharged. This is the empty tank now. Now let us close this valve. And for 10 centimeter height, we have to calculate how much time it takes. So that finally 10 meter height, and finally after 10 meter, this is 10 meter, 10 centimeter is the height of water, and this is the cross section. Then this cross section multiplied with this height 10 centimeter will give you discharge. This will give you velocity, volume, and volume divided by time taken for this to attain the height of 10 centimeter can be calculated. That is discharge. Discharge again. Discharge is equal to cross sectional area of the pipe into velocity. Cross sectional area of the pipe can be calculated by pi by 4 d square. Then Q by A will give you velocity. This velocity, then there is a formula. This formula we have to use in order to calculate friction factor. HF is the loss of head due to friction. 4F V square by 2GD. F is the friction factor, L is the length of the pipe, V is the velocity of water through the pipe, G is acceleration due to gravity, and D is diameter of the pipe. Then from this, as we have to calculate F, so we have found out F is equal to HF 2GD by 4L V square. And how to calculate HF? HF is loss of head due to friction. H2 minus H1 is the manometric head difference, H2 minus H1 multiplied with 13.6. That will give you loss of head due to friction HF. And L is the length of the pipe, which is equal to 2 meter. G is acceleration due to gravity. V is velocity of water. I told you how to calculate the velocity of water through the pipe, and D is the diameter of the pipe, which is equal to 1 inch we have considered in this experiment. Now putting all these values here, HF HIB is H2 minus H1 13.6, and this has been calculated from the manometer reading. And G is acceleration due to gravity, D is 1 inch. 1 inch must be converted into meter, and L is the length of the pipe, which is 2 meter. V we have already calculated. Then putting all these values, we will get friction factor of this pipe. Thank you.